extra-embryonic tissue. My scientists used to tell me stories about human in vivo gastrulation, when the embryo is implanted in the uterine wall and gastrulation occurs with the blastula rearranging to form the endoderm layer, mesoderm layer, and ectoderm layer. But that all changed when it could be visualized with an in vitro model of early anteroposterior organization during human development. No extra embryonic tissue necessary. The human embryonic stem cells mastered in vitro gastrulation. Only the gastruloid could form a 3D aggregate from human ASCs, but when the world needed it most, it vanished. 72 hours have passed, and the other gastruloids are curled or retracted. None are left. 8 years ago, other scientists showed that mouse CSCs could form gastruloids, leaving scientists wondering about me and my fellow human ASCs. Some people believe that studying human development and gastrulation would not be ethically feasible and that embryonic development and disease could not be observed in vitro, but I haven't lost hope. I still believe that somehow gastruloids will be used to save the world.
While creating the Gastruloid protocol, Essential 6-medium, ROCK inhibitor, and embryonic stem cells journey along with Gassy on his journey to find out who he is. Gassy learns of his people's curling retraction limitation at 72 hours. The Wnt agonist, Chiron, primes human embryonic stem cells towards a primitive streak and induces mesodermal differentiation, triggering Gassy's gastruloid state, which in turn alerts the world that the gastruloid has formed in vitro.
Organize the fetus anteriorly. Organize posteriorly. But it was a gastruloid.
Grown by cell signals.
They were organizing using SMAD and Wnt.
Some slugs for motors too.
Gastruloids curl, grow long, and they split.
Image.
Can we immunostain the cell line?
I think SEM may be better.
Can it split into 3 layers?
Endomeso and ectoderm.
How high is the organization?
High enough axially.
Pattern somatogenesis.
Can be done in vitro, but anyway.
Gastruloids in vitro can study disease. Modeled by the Carnegie.
Still seeking axial organization and development, Gassy and crew stumble upon an Ru-S2 GLR reporter cell line to identify cells expressing markers of mesoderm BRA, endoderm SOX17, and neuroectoderm SOX2. Gassy fights against various molecule inhibitors BMP, Wnt, and nodal signaling during pretreatment, showing the importance of BMP and Chiron for proper patterning and elongation, as well as the importance of levels of nodal and Wnt signaling in cell fate decisions and elongation promotion.
Hey, what kind of keepings keep a gastruloid elongating? EUMs, BRA, MISO1, and other things. I associate them with pre-aggregation cells.
Cells.
There's genes MEOX and MESP, TCF patterning and differentiating, making them mirror the coaxial mesoderm. The patterns conserved.
Carnegie stage 8 to Carnegie 9. The human embryos, they seem to be fine. Yeah, that 3-day mark, that seems the right ballpark. Gastruloids can study disease, ease. Modeled by the Carnegie.
They said embryos were risky. Or morals, dead. No.
They told me in vivo is scary, but despite what they said, no.
So gastruloids can solve these fears. Now look at what we read. These findings are sound, so listen to what we have said.
Gassy faces new challenges as he enters the cryo-freezing medium and is sectioned for RNA sequencing. He finds reproducible expression between 2 replicates after meeting with the past gastruloid and organizes gene expression patterns.
He told me that the gastruloids would grow to localize. BMP SMAD1 in the front while the gastruloids wiggle live.
Nodule components to the back.
He said that the nodules would tell the gradient to reach to express different signals.
It's like they're growing now.
Hey there, nodules are important to grow.
Sock 17 is not.
Short on time, Gassy has a lot of spatial and pattern organization to understand and master. However, his friends are there to help, and he finds that Wnt expression and nodal signaling occur mostly at the posterior, while BMP is preferentially expressed in the anterior. The signaling and patterning may be similar to that of other mammals, considering conservation and axial patterning with mice. A regulation of patterning seems to be species-specific. In the finale, Gassy must fulfill his destiny and defeat the mystery of early antero-posterior organization during human development.